So we are starting with mass and volume relationship. So we're just finishing up the mole map today, okay? So the moles and volume section. The volume of gases is more predictable than the volume of liquids and solids. Avogadro proposed in his hypothesis that equal volumes of gases at the same temperature and pressure contain equal numbers of particles. Even though different gas particles are not the same size, they are so far apart that their size does not matter. That's what negligible means, in case you're wondering. So usually, like in chapter 13, we go all about the gas pressure stuff. And so gases are normally measured in pressure. We don't measure their pressure instead of their volume. Or we just say that the volume of the gas is the container shape or container's volume, because it's so difficult to measure them. But we can connect volume with our moles at standard temperature and pressure. This is going to be a test question, and I forget if it's an actual test question or if it's like bonus. But I'm going to say standard STP. What does it stand for? And you have to tell me standard temperature and pressure. And then you might get a bonus point if you tell me that temperature is 0 degrees Celsius and pressure is 1 atmosphere. But this information we need to know later on. But we just need to know STP stands for standard temperature and pressure. Okay? And then that we know that at 1 mole at STP is equal to a volume of 22.4 liters. And so we call that 22.4 liters molar volume of a gas. Thank you. It's still warm. I don't know much anymore. I finished eating the breakfast pizza from first hour for lunch. So, okay, so looking at our mole map quickly, we have filled in the grams for mass. We filled in the atoms, molecules, and formula units for the representative particles. So now in the volume, we're going to be dealing with liters. Bless you. So you can put an L for liters up in there, or you can put the word liters. And so anytime you see liters or volume, we're dealing with this circle. So you can see that 22.4 liters is our conversion factor for these in between the mole and the volume circles. Okay? So we're actually only going to do one example because it's pretty easy. And then you're going to do the worksheet. And then when we're done with those 4, we're going to come back to more notes. So for example 9, we need to determine the volume in liters of 0.60 moles of sulfur dioxide at STP. Since we're using our mole map, we're still going to figure out our start and our end. Okay. So what are we starting with? What circle are we starting with in the back? Moles. And where are we going to? What are we trying to find? Liters and volume. Liters, volume, and liters. I'm going to put vol for volume. Then I'm also going to put L in parentheses so I know that my unit is going to be a liter. So now what do I do? .60 moles over 1. Okay. And then we look to our mole map to figure out what comes next. So Thomas and Chase, when I'm looking here and I'm starting in the mole circle and going up to volume, which arrow do I use on the mole map? So I use the 22.4 on top. Okay. Thank you. I'm not married. My mother is. Mrs. Longman. Okay. So now moles cancel away, and are we multiplying or dividing?
Multiplying.
What do you get?
13.44.
13.44. I heard that said in unison, so I'm going to guess it's right.
Yes.
Okay. And so sig figs and unit will be? Liters is a unit. How many sig figs? Does the 0 before count? Does the 0 after count? 2 sig figs. So the 0 before does not count, but the 0 after does. So 13 liters is our correct answer. All right, so we're going to pause now, and you're going to do numbers 1, 2, 3, and 4. Thank you for being quiet now. Remember that density is intensive property. We talked about density in chapter 3, where density D equals mass over volume. Okay, so for gases, density is usually expressed in grams per liter, G/L, and at a specific temperature. So the temperature doesn't matter for us, but I might mention it, okay? Molar volume can be used to determine density of gases at standard temperature and pressure, STP. So we are going to use our 22.4 liters over 1 mole to help us go between molar mass and density. So molar mass has units of grams per mole, and density is grams per liter. So we are just going to use that to change. It's going to be like using the mole map, but we're not actually going to look at the mole map, okay? So, for example 11, the density of a gaseous compound containing carbon and oxygen is found to be 1.964 grams per liter at STP. What's the molar mass of this compound? Okay, so we're still going to figure out our start and our end, like we did before. And we're just going to use the units. So what are we starting with here? Density, which is grams per liter. Okay? And we want to know the molar mass. And back last week when we were doing molar mass, I was harping this down. What's the units on molar mass? Grams per mole. So the only thing different between these two things is the bottom unit on the starting point on density is liters, and then the bottom unit in molar mass is moles. Okay? So we're going to use our 22.4 liters is equal to 1 mole to be able to switch that around and be left with what we need to in the bottom. Okay? So we're still going to put the number we start with over 1. So we're going to have 1.964 over 1. But for the unit, this is called a complex unit. So normally, in everything up to here, we've just had a 1 without any unit down here. Okay? You're supposed to. But now, since this is complex and we need to cancel something away from it, we're going to split it up. So we're going to put the grams on top, like how it comes first, and then we're going to put the liter on the bottom with the 1. Okay? So then now, we can set up with the 22.4 liters in 1 mole so that we are canceling away liters and being left with the moles that we want. So, to cancel the liters away, should I put the 22.4 on top or on bottom? On top. So by doing that, I'll put the 1 mole on the bottom, and then the liters cancel away, which is what we want because we want to have grams over moles, which is there for us. So when you multiply those, what do you get? No, you need to multiply. 9936.
Yep.
Perfect. Okay. Whew. How many sig figs do we round to? 4. So that answer will be 43.99. And then our unit is going to be G/moles. Grams/moles. Thank you, Jay, so much. Because we need it in molar mass units. Okay? I'm not going to do example 12 with you because example 12 is the same exact process, and I need to change that. But on your paper that you need to finish up, the moles and volume paper, number 5 is in the same format. Number 6, you're going from molar mass to density. So you're going to have to find the molar mass of neon on your periodic table and go from there. Okay? When you have these all 6 done, check them and turn it in, and make sure you have everything else in you need to. Please and thank you.